Well, good morning or good afternoon, whenever you're watching this video. Hope this finds you well. This is a little talk on object-oriented programming in Python, and this was intended to be given as a lab or optional lab, and so the material is best given in an interactive way, but we just decided to put out this video for the first time, get a little feedback on it, and see if we could work this in either as the last lab in CS203 or as an optional lab onto CS203. And I put these charts together when the advent of code was starting on 1 December. So just ignore that, although advent of code is still going on. If you're looking for some coding practice and you haven't explored advent of code, I think it's pretty accessible to most students, and kind of a good way to get some programming practice in whatever language you want to use and whatever paradigm you want to use. What we wanted to do was to present how to do OOP in Java for a couple different reasons. One, at UAB, the way the courses are taught, as like most universities, the first course is on procedural programming, and Python is used as the language. And then there's a follow-on course which teaches object-oriented programming paradigm, and Java is used for that language. And like most universities, UAB wants us to have experience in a couple different programming paradigms and experience in a couple different languages. But a lot of times the way that that's laid out, some students mistakenly think that they can not do OOP in Python, or they can only do OOP in Java. Those are actually both multi-paradigm languages. They also dabble in some other paradigms like functional programming, although neither of them are pure functional programming languages. But the idea is that UAB wanted us to have experience with a couple different languages, a couple different paradigms. And so some students mistakenly get the belief that they can only do OOP in Java. On the other hand, even students, I think, that understand that they can do OOP in Python just are never really presented with the syntax. So the intent of this is to kind of present the syntax for doing OOP in Python. It's useful in a couple of the courses. If you take CS303 algorithms and data structures, most professors that teach that will allow you to use any language, but there are some algorithms and data structures that require the OOP paradigm. So you can use Python for that. If you take CS352 Automata, then you'll definitely be using Python and OOP in that. And then there's a lot of real world applications that use OOP in Python because it's really easy to mock it up in Python very quickly and model whatever it is you're trying to solve, and then get some results. And then if you need more speed or other tools, then you can move to other languages. Currently, there's no course that presents OOP in Python. And this is really not intended to be a whole course, just like an intro to the syntax. I should also say that I am no Python expert, but I'll try to provide you some references and links if you want to go deeper. So this talk will give you the high-level syntax for Python OOP, and it assumes that you've completed CS203 or you're finishing up this semester, and so you're familiar with the OOP concepts and you're familiar with OOP Java syntax, because I'll refer back to that a couple of times. If you haven't done that yet and you've stumbled on this video, then you might want to go back and refresh on some of those things. But I will start just for a couple seconds by talking about what OOP is, or refreshing OOP concepts in our minds. One of the frustrating things for me in CS is that a lot of times there's no official definitions for things, like no universally agreed definitions. So what I'm going to give you are kind of my definitions and understandings of the way that I think about it. Obviously, if this is different from what Dr. Unan has told you in 203 and you're about to take the final, then go with what Dr. Unan says on the final. But hopefully this will be helpful for our discussion for the next few slides. OOP in my mind really consists of this idea of classes and objects. And the idea is that the classes form the templates that we use to create or instantiate our objects from. You might have different mental models for how this works. For a lot of people, their mental model is that the classes are the blueprints and the objects are the buildings that we build off those blueprints. I think that's a great mental model. Some other people might think about a cookie cutter, and so maybe the class is the cookie cutter, and then we'll cut out cookies, which are the objects, and I think that's also a great mental model. Whatever your mental model is, the bottom line is that the objects are what does the work. So the classes define the objects, but the objects are what we will actually use to do our work. A lot of times we talk about OOP in terms of three concepts, and those are encapsulation, and this idea that we've combined the data with the behavior all into one. Contrast that with procedural programming, where you've got data strewn about and you've got lots of procedures that you can run. And for the most part, you can perform any procedure on any piece of data, given certain scoping limitations. In OOP, we're going to combine that together. So we've got the data in the form of instance variables, and we've got the behavior in the form of methods, and we're going to put that together in one capsule so that our class has the data that we need to operate on and the way that we're going to operate on that data all together. Another way that you might think about that is the data are the things that the class or the object knows, and the methods are the things that the object can do. And so that's one of the ways that I think about when I'm modeling things in OOP. What kind of things should my class know about? And those make for good data instance variables. And then what kind of things should the class do? That's the behavior. Those make for good methods. Those are the verbs or the action words of the class. So that's kind of encapsulation to bringing together the data and the methods. Another idea associated with that is this idea of information hiding. And so now that we've got our data and our behavior together in one capsule in our class, we probably want to hide our data from others. We don't want people messing with our instance variables. And so in Java, the way that we do that is with keywords like public, private, protected, which define the scope of, public means anyone can see maybe our data. Private means only our class can see our data. And also we tend to write getters and setters as methods. So that way, if people do need to access the data, it's through an API that we've defined through the getters and setters. So that's the idea of encapsulation and information hiding. Then there's another concept of inheritance. And the idea is that there are parent classes and child classes, and then the children inherit from the parents. So that way it kind of saves us on some of the code writing and also helps us to model things a little bit better. So because in the real world, in living organisms at least, we can see that inheritance play out. Then an associated idea with that is the idea of polymorphism, and this idea that depending on the context, things can take on different meanings or multiple meanings. In Java, we tend to describe that as overriding. So we'll write a method with the same signature as a parent method, and then in Java, that child method will override the parent's method. We also have a concept in Java, which is overloading. And so in that case, the method has a slightly different signature. Maybe in the parent, the method only takes a string. And in the child, maybe it can take 2 integers. And so depending on the signature, that determines which method is called. And overloading is not strictly an inheritance idea. You can also have overloading within the same class, but typically we kind of bundle those together, overriding and overloading, in the idea under this overriding idea of polymorphism. So with that, that's kind of a quick overview of thinking about the concepts. Now let's start writing some code, and we will start with just some very basic classes, and then we will kind of build off from there. So what I'm going to do is I am going to switch. I'm going to be using Visual Studio Code, but you can use any kind of editor that you want. And I'm going to start with the very, very basics, which is if I want to create a class, I just use the keyword class, lowercase, and then I give it a name. And so for today, I thought maybe we'd build cats. I think if you've taken 2 or 3, you've probably built some cats before. I'm just going to use the keyword pass, which just basically means don't do anything. So that in its simplest form is a cat class. So let's create some objects off of that class. And the way that I'm going to do this, I'm going to start off by creating what maybe you would think of as a main method in Java, but this is kind of the Python way of doing it. I'm going to say if underscore underscore name underscore underscore equals equals quote mark underscore underscore main. underscore underscore. Oops, I might have too many there. Underscore underscore. And this is not strictly OOP. This is just a Pythonism. And what this allows us to do is if we call this code directly, then this will be, the main will be called here. But if we put this in with a lot of other code, maybe we've got some other classes, and this doesn't get called directly, we can import class into that other code, and that code's main will run. So this little piece of code just checks to see if we're running this code directly. And so this, you can write kind of your test cases in here if you want. So what I'm going to do to create a cat object similar to Java, I'm going to give it a variable name, and I'm going to say it's equal to, and then I'm going to call its constructor, which is just the same name as this class here, cat, with open and close parentheses. And in this case, I didn't define a constructor. We'll talk about that in a second, but I got a default constructor given to me. And so now I can just print out cat1. Okay, so let's just run that and see if it runs. And what you can see down here is that we basically just get this little printout that shows us that we've got a cat object. So in Python, you might not know this, but pretty much everything in Python is an object, which is kind of nice. So it's kind of things that we can kind of get now. It's object ID, which is kind of unique to each object. So that's nice, but it doesn't really do anything, right? So let's make it do anything. And the first thing that we need to do is we need to define a constructor. So the way that we will do that in Python is we'll say diff or def for basically a function definition, and we'll use this dunder or double underline method called init. So it'll be underline underline init underline underline, and then we'll have parentheses. The first thing that goes in the parentheses is always self, and then after that you can put any other variables that you want to be passed in when the constructor is called. So if you just put self by itself, then nothing will get passed in, and you can use this to instantiate your cat object. But let's make it a little more interesting. Let's pass in the name and the age of the cat. And then in Python, we put a colon afterwards. That's this right here is just a standard function syntax in Python. The only thing that's different is I've called this dunder function, or this double underline function or method, and init basically means initialize, and we're going to use that to initialize our object, or basically this will be our constructor. Then the way that we set up instance variables is we use the keyword self, and then we use the dot notation, and then we give it whatever variable name that we want. In this case, I'll call it name, and then I'm going to set it equal to this name that we passed in. So this is just basically setting up my initial, and then I will say self.age equals age, and I could create any other instance variables that I wanted. If I want to, I can, self dot whatever variable that I want. And I could also set initial values to them as well. And actually, I think if you set them up here, you have to set initial values to them. But for now, I'm just going to have a self.name and a self.age. And then I'll just say, I'm just going to print here. This is not strictly required, but I just want to highlight this. I'm going to use an fprint statement. So basically then this formats it for me. So I'm going to say self.name created. So that way, every time I create a new object, a new cat object, it'll just print out its name. So these curly braces here just means find this variable and insert it in this string, and then it'll just say name created. Okay, so I'm going to keep this code the same, and I'm just going to run it again. Let's run it this way. Oh, Yes, we have an error. The reason that we have an error is because I called cat with an empty constructor, and I said, "Hey, I need two things here. So I need to pass in a name, basically a string, and then an age." So let's just save that and run that. Okay. And you can see that it printed out, hey, Garfield was created, and then it printed out the object ID because I asked it to print cat again. Okay, so that's kind of the very, very basics, right? We have a basic cat object, and we've got a constructor. Now, if I want to call instance variables on that, then the way that I would do that down here, I could say print. I'll just do an F string again. And if I want to call like the cat's age, I just use the object name, so cat1, and the dot notation, dot. And then you can see I can pick a name off of here. Or I could pick age off of here. You know, I can have access to any of the instance variables by just using the dot notation. So I'll just say is blank years old. Okay, so that's the way, pretty much like instead of using the getters and setters in Java, then you would just use that dot notation to get at the any of these instance variables here. Let me run this and make sure it runs. Yep, and you can see it printed out is 2 years old. Okay, and then we can create methods. Similar way, we just define the method, we give it a name. Let's just say we want it to purr. Again, we have to start off with self as the first parameter into the method. And if we want to have anything else passed in, we put a comma and then identify anything else we want passed in. In this case, I'm just going to have nothing passed in. And I'm just going to say if self.age is greater than 1, then we'll print per. And then if not, I'm not actually sure if this is true. I think maybe aren't kittens too young to purr at some point? I'll just write this. I think 1 is way too old, but showing my lack of cat knowledge here. And then if we want to call that method, wait, I got to get my F in the right place here. If we want to call that method, then again, just like in Java, we give it the object name, the dot notation, and then the method name followed by parentheses. And then inside the parentheses, we would pass in any arguments to that method that we wanted. In this case, it doesn't take any arguments, so we won't pass any in. So let's save that. And cool. And in this case, because we're greater than 1 year old, then this cat knows how to purr. Okay, so that is the very basics. We have a cat class that we stood up. We have a constructor by using the init dunder. We've got instance variables. We have behavior in the form of methods. We could take arguments or not take arguments. One thing to keep in mind, if you don't pass in self, then this becomes a static, I'll call it my static method. So if I don't pass in self, then that's the way that the static methods work if you need to create static methods. Again, static meaning there's only one of these for the class. So every object that gets created will share this one method. Same with static variables. We could have static variables by putting them up here before our constructor. And so I could say number of legs equals 4. And therefore, every cat object that we create will share this one variable number of legs. Now, the way that you would get at these static methods is that you would call them via the class name. So cat dot my static method would be the proper way to call them. I think you might also be able to call them by calling the object reference as well, but I think this is a little clear. And so the that's the way you would kind of call the static methods and the static variables if you had them, if you felt the need to have those. So with that, you can pretty much get at most of what you would need. So if you stop here and that's all you take away from this video, I think you've got most of what you need, but I want to go through the rest of the concepts of OOP, and for each of the concepts, talk about how you would do it in Python syntax. So the way that the next thing we should talk about is information hiding. And so that really isn't a clear-cut concept in Python. So in Java, you would use the private keyword on your instance variables, and then you would write public getters and setters for anything that you wanted people to be able to access. And then that would provide a mechanism for them to access your private instance variables. In Python, you don't have quite so much control. If you want to create a private one, you can do it by saying self._, let's say type. Maybe we want to type as house cat or something like that. But this doesn't strictly preclude someone from getting access. So I could still say cat1 dot underscore type, and I can still get access to that type. But the underscore is generally used to tell people, hey, this is a private instance variable. You probably shouldn't access this directly. But there's nothing in Python that enforces that strictly, that restricts people from being able to do that. So you can use this for sure. You can use the underline to identify private instance variables. In practice, I think people are just adults about it, and we just kind of say, okay, we got these instance variables, you can just access them. But if you do find yourself in a situation where you need to create some private, truly private instance variables that are enforced, you can create getters and setters by using a couple of annotations. And I first ran across this in a video by Traversy Media. I think his name was Caleb Curry. And I'll put a link down in the description if you want to look at his video, which is pretty good. I would encourage you to do that. But he was the first person that I saw that described this. I had to go looking for this quite a lot. But the way that you would do this is you would use this annotation called @property. And then you would define, your function. We'll call this last name. And you would pass in the self. Oops. Need to get my colon outside the parentheses there. And I'm going to put I'm going to kind of print out here. We used this is going to be the getter. That way, if we end up calling this, we'll know when it gets called. And then we're just going to return self dot last name. Oops, definitely didn't need all that. And then that'll be the getter. And then for the setter, we'll use at, and then whatever we call this thing, so last name dot setter. We use that attribute. And then again, we will define our setter function. We use the same method name, and we'll always have the self, so that way it's not static. And then obviously this one will need to take at least one argument, the one that we want to set. And then I'm going to also do the same thing. I will write a little print statement in here. We call the setter. And then I will say self dot last name equals last name. Okay. I will put a return in here. You don't need a return. A lot of times I will put returns at the end of my functions just out of habit, but you don't need to do that. Okay, so now we've got our getter here. And I know this looks a little funky, and we've got our setter here. And now we can use those, though, just like we used the instance variable before. So we'll just say cat1 dot last name equals Smith. And then we can print out, we'll say cat1 name, which is the first name. And then we'll say cat1 last name. So this first line should call the setter here, and then it should run this piece of code. So we should also see a printout that said, hey, we called the setter. And then this next line here should call this getter. So we should see a line that says, hey, we used the getter. So let's run that. Oh, got an error in line 16. It doesn't like my indentation. Oh, because I didn't put anything in here. The one thing I do not like about Python, and I'm sure you've experienced the same thing, if you don't get your indentation set up correctly, then it gets really crazy, and sometimes it can be maddening. It looks like it's all lined up, and you have to go through all of your code and set it up. So, okay, and I got a little recursion situation going on here. And the reason that I've got that is because my my method name is the same as the variable name, so it gets confused. So one thing I'm going to do is I'm going to put an underscore in front of the variable name, and so that way Python knows underscore last name is actually the instance variable, and last name is going to be the method. So let's make that change, and let's run that again. And and now it works correctly. So you can see the first time we called the setter, that was down here in line 35. And then when in line 36, we called the getter, and then it got the instance variable out. So I'll be honest, I hardly ever see this used. In fact, I've never seen it used. I had to go searching for it. But if you need to do that, if you strictly need to control access that way, that is at least one way that you can do it in Python. But for the most part, I don't see people using that. I just see people put their instance variables here, and then their methods down here. And then, we just kind of treat everyone like adults, and everyone kind of follows the rules. Okay. So that's the basics. That's encapsulation. We've got our information, our data encapsulated with our methods or behavior. And it also includes information, the concept of information hiding. So let's talk about our second concept, which is inheritance. And to do that, I want to create another class down here. And I'm just going to start with the keyword class, lowercase. And so for this one, why don't we create a house cat? And then if we want it to inherit from another class, inside parentheses, we just put the class that we want to inherit from. So that is cat. And I'll just put pass right here for now. So now we can create a house, let's say cat2 is a house cat. And then we can, let's print cat2. And I mentioned before the indentation can be maddening. In this case, I'm like 1 space off. Okay. Okay, let's just run that. And you can see that I got an error. It tells me that I'm missing 2 required positional arguments, name and age. And that's because house cat inherited from cat, and cat has this constructor that took 2 arguments. So we inherited that. So I need to put in here, let's see, so if this were interactive, I would ask you for a good name for a cat. Unfortunately, I can't do that. So you're just stuck with whatever my brain can come up with, which is not very creative. So we're going with Mittens. Sounds like a good name for a cat. Okay, and now you can see Mittens was created, and then this object number is different than our cat1 object ID. Okay, so that works just like we would expect, right? We inherited from cat, and we got all the gooey goodness that was in cat. We can also do kind of all the things that we could do with inheritance. We can create our own constructor if we wanted to. We could also, and that would basically override the constructor that we had before. In this case, let's do a method that will override our constructor. Let's say, let's do per, and it also takes a self. And I'm going to print, actually, I'm going to take, I'll just say my name is self.name. So that shows I can access all the same instance variables that I got, that I inherited from my parent. And we'll just say this, and I roar, something like that. And then if we come down here and we say cat2 per, then we should see the overridden method printed instead of its parent method. Yeah, and we did. My name is Mittens and I roar. Okay, and so that is the idea of overriding. There are actually a lot of dunder functions that you might want to override. For example, I'll list some here, some methods you may want to override. And if you search for dunder or double underline, you'll get the full list, but just some that is very common: underscore underscore str underscore underscore. This represents your object as a string. So this would kind of be like toString in Java. Let me write that in there, like toString, in case you're following along. So you can return, and we can just put a string. I'm going to use an F string. So I'll say self.name is self.age. Typing John, typing. Okay. So it will return this string. There's another one which is equal, underline, underline, EQ, underline, underline. And this basically is used to compare two objects. So actually I messed up here. This takes a self and some other object, right? Because you're going to compare the other object that is passed in to this current object. And so typically, and you can use, this is handy because we might want to pick different ways of comparing, whether two objects are the same. In this case, maybe we want to say, hey, if the house cat has the same name, then we're going to call it the same. So we'd say if self.name equals other.name, then we'll return true. I think this has to return a Boolean value. Either true, it's the same, or false, it's not the same. Else we'll return false. So those are two that very commonly you will see overridden. And even if you don't inherit, even if we didn't inherit from house cat, from cat, we might still want to override these even in cat, right? So that's how common it is. You will see this even if there's no inheritance from any other classes that you wrote. The other one that is pretty common, so there's a less than, just like there's an equal, there's a less than, there's a greater than. Also, Python lets you override operators as well. So you can override the add operator, which you can't do in Java, which is kind of cool. And the other one that you can look at is hash. And this basically is useful if you're going to do any kind of hashable data structures. You'll need to define some way to hash your object. So that's a little bit beyond the scope of what we're going to do here, but you might see that as well. Okay, so that is the concept of overriding. And in Java, the way that overriding works is it starts with the class that is called, and if it can find that method inside that class, like down here we called cat2per, so it's going to start looking in the house cat class because cat2 is a house cat. And if it can find it inside that class, then it will stop and execute that method. If it can't find it in that class, then it's going to go up to any parent classes. In this case, it would go up to cat, and it would look for the method there. If it could find it there, it would run it. And if it can't find it, it would keep walking up the inheritance tree. And in Java, the final place it would look would be in the object class. The object class is the parent of all other classes. And so then if it can't find it there, it would throw an exception. Python works pretty much the same way. But with Python, you can also do multiple inheritance. So that's something that you can't do in Java. In Java, you can only do inheritance from one class. And then Java has this, concepts like interfaces, right? Where you could extend a class that you inherit, but then you can implement an interface. And so that is kind of Java's way of getting around the fact that they don't allow multiple inheritance. But in Python, we can do multiple inheritance. And the way that this works is you just take the classes that you want to inherit from and you separate them by commas, and you just keep stringing them together. I'm sure that there is a limit to how many you can inherit from. I actually don't know what that limit is, but for our purposes, you just kind of string them together with commas. So, but this presents some unique challenges, like, okay, what do you get from what class? And so the way that this works in Python is that there is a method resolution order, MRO, and basically it's going to search in this first class, and if it can't find it, then it's going to continue the search through the parent classes from left to right order, doing a depth first search. So usually that's not that big a deal, but it can be complicated. So I would encourage you, if you're going to do multiple inheritance, you're probably going to want to play around with that and make sure that it's working just like you expect it to work. I want to kind of take a look at an example of where that doesn't maybe exactly work like we would think. And this example is from a book called Python Object-Oriented Programming by Lott and Phillips. And the idea here is, let me show you the diagram first. So the idea here is that we're going to have this base class, and then we're going to have a left class that inherits from base, and a right class that inherits from base, and then a subclass that inherits from both left and right. So let's take a look at the code. And I should also mention in Python, you can also call super, and it works pretty much just like it did in Java, right? So that basically is calling your parent, and then you can call the methods on that or instance variables on your parent, especially if you want to mix and match. Very helpful in constructors, as we saw in 203, where you can call your parent and get some of the things that are in the parent's constructor, and then you can have some unique things in the child. Or like in toString, like we saw in 203, where you can call the parent's toString, and then you can concatenate onto that the child string, and then have a unique string. So you can do the same thing in Python using super. So in this case, I've got a class here called the base class, and there's a method here called callMe, and it just prints out, hey, I'm calling the method in the base class. Then I've got the left class, and it inherits from base class. It has a method called callMe, and in this case, it calls super first. It calls the parent's callMe first, right? And then after that, it prints its own little string here. So it says calling method in left class. Similarly, there is a right class that is inherited from base class. It also has a method called callMe. It also calls the parent callMe method first, and then it prints out the calling method in right class. And then finally, we've got our subclass here, which inherits from the left class and the right class. It calls that, it has its own method called callMe. It calls its parent's method callMe, and then it prints out a calling method on subclass. So what we're going to do is we're going to create an object. We're going to call our object S, and it's going to be of the subclass type. So we have an object S, which is a subclass. And so remember, subclass inherits from left class and right class, and they both inherit from the base class. Then we're going to use this dunder, which is __ MRO, and that's going to tell us the method resolution order. So we can look at that. And then we're going to call this method callMe. So what you might expect to happen is that we would call callMe. There is a method here in the subclass called callMe. It's going to call its parent, which should be the left class is callMe, right? And then you would think it would come up here to the left class and call this method callMe, which would call its parent callMe, which would be the base class callMe. So it should come up here and call this method callMe, which should print out calling the method in the base class. Then this would return right to the end of this line, and then it would call the method in the left class. Then this should return down here, and then we should see calling method in the subclass. Right, that is what you would think would happen, but let's take a look at what actually does happen here. And this is called, what did I call this? super.py. If I spell it right, it probably would go better for me. Okay. All right, so the first thing here is it printed out our method resolution order. So this tells us what order we're going to be searching at to resolve our methods. So first we're going to start in the subclass. That makes sense. Then we're going to start in the left class. That makes sense because the left class is the left one in here, right? Then we're going to go to the right class, and then we're going to go to the base class. So it's always going to resolve things in that order. So the thing that is odd here is the way that this works. So the way that this actually, and you can see that this did not print out what we expected. So the way that this actually works is it called our subclass callMe method, which called super. So super checked our MRO and said, hey, the next class in order is the left class. So we're going to go to that one for super. So then it went up here to left class, and it came down here and it found the word super again. So then that checked the MRO, and the next class in the MRO is not the base class. It is this right class right here. So that's maybe the confusing bit, right? So then it came down here to right class. It found this word super, and then it went to MRO again, and it said, hey, base class is next. So then it went up to base class, and then it printed call method in base class, right? Then that returned to the right class, and then it's printed call method in the right class. Then that returned to the left class, call method in left class. Then that finally returned to our subclass, call method in subclass. So my point in saying all that is that you probably want to check the MRO just if you're going to use multiple inheritance, just to make sure that the inheritance is set up the way that you expect it to be. Also, if you're going to use the word super in particular, you probably just want to be careful that you are getting the right super that you're expecting. For single inheritance, it'll work exactly the way that you're used to in Java, but for multiple inheritance, because you haven't had that in Java, it is a little bit quirky, and it doesn't exactly work, at least the way that I would expect if I just read the code, if I didn't kind of check out the MRO first. So just be a little careful with that, but you can do multiple inheritance with Python. I think that's pretty cool capability that you didn't have with Java. Okay, the last concept we need to talk about is overloading. And to be honest, I can't really find anything specifically that matches Java's overloading. There is this concept in Python of Variadic Functions. And I will call it, I'll write it this way so you can see Variadic functions, which just means that they take multiple or variable number of arguments. And this is, I'll put some references in the description box down below if you want to check this out, because it's probably a little bit beyond. This is not really specific to OOP for sure. This is just a general concept in Python and several other languages. But the idea is that we can pass in different numbers of arguments. And you will see this a lot with print, right? So I can say, I can maybe say print, and I could pass in one argument, or I could separate them by commas and I could pass in 3 arguments, right? And print knows how to take either one argument and print it out, or 3 arguments and print it out, because it's a variadic function. And so we can write our own variadic functions in Python as well. One thing you'll have to keep in mind is that there is this concept of positional arguments. And so for the most part, we've been using positional arguments where the first argument passed in gets assigned to this, this parameter, and then the second argument passed in would get assigned to this parameter. So those are kind of called positional parameters that take positional arguments. But you can also have this concept of keyword. So for that, we could pass in something that looks like this, where we've got a key value and a key and then a value for it. So those are the 2 types of parameters that we can have. And the reason I bring that up is because depending on what you have, what you want, you can use a couple different syntaxes for it. And typically we'll use this word args and then corgs, but what's important are these little asterisks. So if instead of having 1 and 2, if I say asterisk args, then what'll happen is however many positional arguments are passed in will get assigned to this list args, and then we can iterate through the list and get out the arguments and then do whatever we want inside our function. Similarly, there's another idea for corgs. You do asterisk corgs. Again, you can use any name you want. You don't have to use args or corgs, but that is what you'll see a lot. What's most important are these asterisks. So 1 asterisk asterisks for the positional and 2 asterisks for the keyword. And then what this in quargs, what you'll get out is a dictionary of key value pairs, and then you can get out whatever you want there. So if you set up your function as a variadic function, you can kind of get at the overriding concept in Java, where, you know, depending on the signature of the function, then it'll depend on what the function does. But it's not purely the same as overriding in Java, but it's similar to that. And then inside the code here, you'll have to have some logic to you know, parse out args and quargs, and then do whatever you want with it. So that's kind of the closest that I think we can get to overloading in Python. Okay, so that was a lot of stuff. We covered basically how to set up a class, just using the keyword class, and then the name, and then a colon. If we want it to inherit, then we put any classes that it inherits inside these parentheses, and we can just separate them by commas. We can put as many as we want. The way that we do constructors is we use this dunder method called init. Remember that the first parameter into all of the methods inside our class is the keyword self, and that basically refers to this object. And then we can put any other parameters in that we want, separated by commas. For our constructor, then we just say self dot whatever the instance variable name is, and then we can set it equal to the argument that comes in. And then throughout our code, we can use that same, you know, self dot syntax to get at our instance variables. Methods are just, you know, functions that are defined, again, with the keyword self. If we don't have a keyword self, then that basically is a static method inside our class. There is a way that we can enforce information hiding, although I've never seen it used, but I provided it to you just in case you want to look at it. And then again, the way that we instantiate our objects is very similar to Java. We give it a name, then we call the class name, and then we pass in any arguments that the constructor takes, and then we can call methods on it using the dot notation, just like Java. And then we can also get at our instance variables also using the instance, or using the dot notation. So not like Java where we use the getters and setters per se, although you certainly could create getters and setters if you wanted to, but typically in Python, we don't spend time with that. We just kind of keep it very simple. So hopefully that's helpful. Would definitely like to get your feedback. And I will leave a link to my email in the description section, but it's bedingjd@uab.edu. And we will take all of your feedback and improve this to hopefully give this as either an added lab or an optional lab into CS203. And hopefully this, if you give me good feedback, that can go to the students that come after you to give them good feedback. So that way we can kind of set them up for success as they explore doing OOP in Python. Again, appreciate any and all feedback. Hopefully this helps you. Have a good day.